Okay, so hi there, folks. In this video, we're going to talk about this is going to continue our set of videos, by the way, in factorization. So this is part of college algebra, and here we're going to talk about the quadratic trinomials, or at least the simple case of it. Okay, so in quadratic trinomials, the simple case is this one. To make it fairly more simple, let's imagine our trinomial, our general trinomial is a times ax squared plus bx. Does it look like a b? Bx plus c. Okay. Seldom you put an equal 0 there, but let's be contented. Okay, let's put it there. Okay, so we have here ax squared plus bx plus c. This is the general formula of quadratic trinomials. And what we want to do here is we want to factor them into two separate binomials. Okay. Now, how do we do the factorization? For the simple case in this video, we're going to settle ourselves with a simple case. That is 1 should be strictly equal to, or rather, a should be strictly equal to 1. The leading coefficient, the first coefficient here on the x squared, should be equal to 1. So as you can see, the x squared term here doesn't have any coefficient because it's automatically 1. Now, how do we factor them if a is equal to 1? So this is the simple case. How do we factor them? Our b, okay, our second coefficient will be the sum of um, two numbers, and our c, our last coefficient, our constant term rather, will be the product of two numbers. As you can see, the numbers here are common. Okay, we have the a plus the b, we have the a times the b, actually because they will be separated in this way. We have the first grouping, which is x plus a. Notice the x is written because it's x squared. And we have also in our second grouping, we have x plus b. Okay, so how did we end up in this? Okay, so if we're going to factor this using the FOIL method, first you have x squared, um, outer, we have the plus bx, I'll continue down below, okay, plus inner ax plus last terms ab plus ab. Okay, now if we're going to simplify this, we can combine bx and ax terms. So this will be equal to x squared plus a plus b x plus ab. I cannot fit it. Okay, which is exactly, this one is exactly this. Okay, exactly this. Okay, so in essence, what are we thinking? The last term, always the last term is a fact, there are two factors of it. These two factors, when added or combined, will be the middle coefficient. Again, our constant term, it should be factored, and one of its factors, when added together, will become the middle term. So let's try, for example, here. So we will always look to it as this. Okay, since x is our leading coefficient, or leading term rather, we have x here and then x here. That's our thing that should be thought of. Now the next question is, what should be written in this part and also in this part, in the boxes, including the signs? So what should be written there? Okay, so we need to investigate what is our last term. Our last term is negative 4. Negative 4. And we need to think of the factors of negative 4 when added will become positive 3. Okay, again, we need to think of the factors of negative 4 when added will become positive 3. Now let's think of negative 4 first, shall we? So negative 4, it's negative, and by our multiplication rules, we will end up only in negative numbers if we multiply two unlike signed integers. Okay, two unlike signed integers. So it can be like, negative 4 times 1 It can be positive 4 times negative 1. What are the other factors of 4? 2 times 2. Negative 2 times 2. Or if you want commutativity, it's still the same. Okay, so which one of these factors, I'm going to box them one by one. Okay, which one of them, when added together, will become positive 3? So we can see here that it's positive 3. Now, when we're adding integers again, and knowing that they are two different signed integers, when adding them, we should take note that the bigger number, okay, the one with the bigger absolute value, should be positive since it ended up as positive. So will this give us positive 3? No, actually, when added, this will become negative 3. Will this give us negative 3? No, when added, this will become 0. This will give us 0. No. Here, 4 plus minus 1. Will this give us positive 3? Well, yes, actually, this will give us positive 3. So what are the two terms here? It should be x plus 4 and x minus 1. And those are it. Okay, so those are the answers for our number 1. X plus 4 and x minus 1. Okay, that is how we factor. Okay, let's have another example in number 2. Okay, so we have x squared minus 7x minus 18. So let's write it this way. X times x plus something. Okay, now we're going to look at our last term. Okay, negative 18. So it's again negative. And we're going to multiply two numbers which are unlike signs. And maybe we can think in advance, our middle term is also negative. So therefore, the bigger number should be the one which is negative. Since if we're adding, adding different signs, if you can remember, we're going to proceed to subtraction and then copy the sign of the bigger number. So that's it. So what is it gonna be? So what are the factors of 18? So let's try to think of negative 18. Also take note, the bigger number should be the one which is negative 18 plus 1. Nah, that's not gonna give us negative 7. Instead, it's gonna give us negative 17. What else? 2 times 8, or rather 2 times 9 rather, let's try that. Negative 9 plus 2. Yeah, will this give us negative 7? Well, yeah, this will give us negative 7. Okay, in the same time, it will give us negative 18. So therefore, the two numbers that we needed in number 2 is minus 9, x minus 9 times quantity of x plus 2. Okay, and that is our answer in the second term, in the second number. Okay, that's in the second number. Okay, hopefully you got it. Let's have more examples here so that you can understand it more. Okay, let's have it here. Next, for number 3, x squared plus 9x plus 18. So let's ready already these two binomials here. Okay, so what are we going to put it here and here? So that we have now positive 18. So positive 18 can be, a multiplication of two like integers, like signed integers. So it could be both positive or both negative. Here, but we look at our middle term, we see that it's a positive number. So when we're adding numbers which are both negative, the result is also negative. So therefore, we will only restrict ourselves with all positive integers. Since if we're going to multiply both positive integers, it will give us positive. If we're going to add two positive integers, it will also give us positive integers. So let's try. Is 18 times 2 will work? Or rather, 18 times 1 rather? Will this work? 18 plus 1? No, it's not going to give us 9. It's going to give us 19. Wrong. 9 times 2. Okay, how about this? 9 times 2. Will this give us 18? Yes. Will this give us 9? Probably not. Okay, probably not. Okay, so, nuh-uh. What else? What are the other factors of 18? Okay, how about this? 3 times 6. Okay, 3 times 6 is 18. Okay, 18 is a multiple of 6. 6, 12, 18. And how about this? Look at this. 3 plus 6 is 9. So this is the two numbers that we're looking for. Okay, so we have x, quantity x plus 3, and quantity x plus 6. And these are the numbers. Okay, these are the numbers. Okay, hopefully you got it there now. Okay, next up, number 4. So we have number 4 here. So let's ready already our two binomials. Okay, so we have x squared plus 7x plus 10. So again, we're going to look at this positive 10. 10, what are the factors of 10 that will give us 7? Let's try first with a 10 times 1. Okay, that's not going to give us 7, that's going to give us 9. Anyways, this is positive, this is also positive, the same case with number 3. So we are looking forward for two integers which are both positive. Okay, so 10 times 1 will not work. How about this? 5 times 2. So 5 times 2. Yeah, it's equal to 10. How about 5 plus 2? And yes, it is equal to 7. So therefore, these are the two numbers that we're looking for. So what are the answer? X, quantity x, what is the answer? X plus 5 times the quantity of x plus 2. And this is our answer for number 4. Okay? So x plus 5 times the quantity of x plus 2 to give us this trinomial. Okay? Moving on for our last batch of examples here. Okay, let's put it already in this form. X, x. Okay, now let's look at this. This is negative 12. So this is negative. So again, in negative, we are expecting two unlike signs. Two unlike signs. And notice our middle term here, it's positive. Actually, it's positive 1. Now, if it's positive 1 and we have two unlike terms, meaning we should look into it that our factors, the bigger number should be the one which is positive, since we're adding them. If we're adding them, it will end up into a positive one. So what are the factors of 12 again? So let's try 12 times negative 1. Will it give us positive 1? No, indeed. How about this? 6 times 2. 6 times negative 2. Yeah, will adding them give us negative 1? Positive 1 rather? No, indeed. How about this? 4 times negative 3. Yeah, adding them will give us negative 12. How about, or rather multiplying them, sorry, multiplying them will give us negative 12. How about adding them? 4 plus negative 3, yeah, well, that will give us positive 1, indeed. Okay, and these are the numbers that we're looking for. Okay, so our answer will be x plus 4 times the quantity of x minus 3. X minus 3. So this is our answer in number 5. Okay, this is our answer for number 5. And lastly, for number 6, okay, notice here in number 6, one thing to notice here, we have x squared. Okay. And notice we have a y in the middle term. What happened? Why? Okay. Because we have also a y squared in the last term. In our C, in our AB. So since it's y squared, we're expecting that we're multiplying y's on the last term. So it should look like x times something y. There is a coefficient here in y. There's no coefficient in x because this is a simple term. A should be 1. The leading coefficient should be 1. So we don't know what is here, but we're sure there's a y because by multiplying the last terms, y times y will give us y squared. So what are the numbers here that we should put? Okay, in such a way that it will give us negative 8. Maybe we can forget of the y now because we fixed that it has y's here. But what number will if we multiply, it's going to give us negative 8, and when added, it will give us negative 2. Again, since it's negative, we're expecting two unlike signs, and since the middle term is negative, we're expecting that the bigger number, the one with the bigger absolute number, will be negative. So what are the factors of 8? So let's start with negative 8 times 1. Will it give us 2? Nada. Okay, what are the others? Let's try negative 4 times 2. Okay, so negative 4 times 2 will give us negative 8. Negative 4 plus 2 will give us, yeah, it will give us negative 2, indeed. And yeah, these are the numbers that we're looking for. Okay, negative 4 and positive 2. Negative 4 and positive 2. So we're going to write it here. X minus 4y, first grouping, times the quantity of x plus 2y. And this is our answer for number 6. Okay, this is our answer for number 6. Okay, so that is it for our quadratic trinomials. Hopefully you learned something there. Again, if you have some difficulty in anything at all, you can, rewatch this, rewind for the things that isn't clear for you guys. And yeah, this is just a simple case. It's just a simple case. We're going to have the not simple case later, okay, in the videos later. Yeah, and that's it for this video. Again, rewatch if there's something that you need to clarify yourself, okay? And yeah, don't forget to like and subscribe. Okay, thank you for watching, and yeah, I'll see you soon. Bye.